Good morning, students. This is the last topic of thermodynamics chapter, that is third law of thermodynamics. If we complete this topic, then this chapter will be finished. Here the statement for third law of thermodynamics is the entropy of pure and perfectly crystalline substance is zero at absolute zero. Absolute zero means what? What is absolute zero? 0 Kelvin temperature or minus 273 degrees Celsius temperature. 0 Kelvin temperature or minus 273 degrees Celsius temperature is called absolute temperature. That is very low temperature. Suppose if you put a bottle of water in fridge, after one day that liquid is converted into, it will convert it to solid. In fridge, minimum and maximum temperatures are minus 5 and minus 10 degrees temperatures. That means at that temperature liquid is not exist. Then you can imagine that minus 273 degrees Celsius is how much it is having, how much temperature, less temperature. At that temperature only solids exist. There is no existence of liquids and gases. If you take solids, the particles are closely packed by intermolecular forces or stronger intermolecular forces. When the particles are held by stronger intermolecular forces, then attractions will be very high. When the attractions are high, then there is no movement of particles in solid state. If there is no movement of particles in solid state, then their entropy will be zero. That is the meaning of that point. So at absolute zero, there is no chance of movement of any particles in solid state, so that its entropy will be zero. That is the statement given by third law of thermodynamics. Here one more relation is there for that, that is here some relations are there regarding numericals. That is the relation between delta G, nothing but change in Gibbs energy, equilibrium constant, nothing but Kc is given by delta G is equal to delta G naught plus RT ln Kc. Delta G means what? Gibbs energy change or change in Gibbs energy. Delta G naught means Gibbs energy change under standard conditions, nothing but standard Gibbs energy change. Then what about R? R is universal gas constant, T is temperature. Kc is called equilibrium constant. We will discuss about it in next chapter, that is chemical equilibrium chapter. Until then you just remember about that. At the equilibrium conditions, we know that delta G will be 0. Then delta G naught become minus RT ln Kc. Then delta G naught equal to minus 2.303 RT log Kc. So ln means what? Natural logarithm. Log means what? Common logarithm. If natural logarithm is converted into common logarithm, it should be multiplied by 2.03. If suppose if you want to convert a common logarithm into natural logarithm, then that value will be divided by 2.303. So this is the final relation between delta G naught and Kc, where delta G naught means what? Standard Gibbs energy change. Kc is what? Equilibrium constant. The relation between delta G and work done in an electrical cell is given by delta G equal to minus NF E cell. The relation between delta G and work done in an electrical cell is given by delta G equal to minus NF E cell. This is E cell means EMF of the cell, F means Faraday's, N means number of electrons in that electrolytic cell. Delta G means what? Gibbs energy change. One Faraday value is so much? 96,500 kilograms. These two formulas, you have to remember these two formulas. You will get some problems based on these two formulas. I will discuss some numericals. In this numerical, we have to find entropy change in surroundings, entropy of surroundings, when 1 mole of H2O is formed under standard conditions. Delta H is also given. That means delta H is given. You have to find delta H surroundings. Delta H surroundings is equal to minus delta H system by T. This is given for here. If you see this question carefully, that is system. When 1 mole of H2 is formed under standard conditions, that is the system. Then delta S surrounding is equal to minus delta H system by T. This is the formula. Then if you substitute this value here, standard condition, what is the value of temperature? 298 Kelvin temperature. Then you get delta S surroundings value. Next, one more numerical. The equilibrium constant for a reaction is 10. That means Kc is given. What will be the value of delta G naught? Delta G naught. That means you have to find delta G naught. What is the relation between delta G naught and Kc? Delta G naught equal to minus 2.303 RT Kc. Minus 2.303 RT Kc. If you substitute the Kc value in this equation, then you get value of delta G naught. Next, one more question, that is, for the oxidation of iron, this is the oxidation of iron reaction, the enthalpy change is, that means delta H is given at 298 Kelvin temperature, though it has negative entropy energy. That means it is having entropy which possesses negative value, but reaction is spontaneous. Why? What is the meaning of the question? One reaction is given. For that reaction, entropy change is also given. Even it is negative value, why it is spontaneous? That means we should show that the reaction is spontaneous. What is the condition to show spontaneous? Delta G should be negative. How delta G should be negative? Already delta H is given in question itself. In question itself, delta H is given. So no need to find delta H value. Delta H surrounding is equal to minus delta H system by T. If you substitute this value in this equation, then you get delta S surroundings. After finding delta S surroundings, already delta S system is given. Delta S system plus delta S surroundings equal to how much? Delta S total. If delta S total is positive, that also will be spontaneous. That is one way to find this type of question. One more way is there. That is what? We can use direct formula. Delta G equal to delta H minus T delta S. Already delta H is given, delta S is also given. If that value is negative, then that will be spontaneous. That's all. That is the way to calculate that problem. Next, one more question is there. That is, calculate delta G naught reaction for conversion of oxygen to ozone at 298 Kelvin. Kp for the reaction is. That means in this question also Kp is given. We have to find delta G naught. Delta G naught equal to minus 2.303 RT log Kp. If you substitute Kp value directly, then you get a value. This is the way to solve such type of questions. This is the end of thermodynamics chapter. Thank you.